In the fifth part of our science series, we're going to be looking at electricity. It is the phenomenon caused by positive and negative charges. And we're going to be looking first at static electricity, dealing with the imbalance of electrical charges at rest, then dynamic electricity, dealing with the motion of negative charges carried by electrons. As a review in the periodic table, we must understand how the atom is constructed. It's composed of a nucleus, which contains neutrons and protons, and then it's orbited or circulated by electrons in shells. A positively charged body is something that has fewer electrons than protons, so it has an overall positive net charge, while a negatively charged body is something that has more electrons than protons, so it has an overall negative charge. Static electricity deals with the electrical phenomenon with non-moving particles, where electrically charged objects have an imbalance of charges. The imbalance can be positive or negative. Key thing with static electricity is that charged objects do not stay permanently charged, and we can lose it very quickly or even gradually. Two ways of charging objects: naturally, something prompted to lose it just wore off, or something called electrostatic discharge, which is a negatively charged object touches and comes in close contact with a positively charged object. For example, when you shock somebody from your finger when you're walking on a carpet with your socks. Three ways to charge objects using static electricity. Friction is number one. We're rubbing two objects, neutral objects together. Conduction, putting a neutral object in direct contact with a charged object. And induction is putting a charged object near a neutral object without physically touching it. Friction, rubbing of two neutral bodies. One body will become negatively charged and the other one will become positively charged. And this is the electrostatic series, or friction tendency charge, which describes the relationships of transfer of charges between one object to another using friction. For example, if I were to rub wool with plastic, the net charge, the plastic would end up having a net charge which is negative, and the wool would end up having a net charge which is positive. Static electricity, as you can see here, rubbing one object from another. For example, the wool will lose electrons and transfer it to the plastic. The plastic will have a net negative charge, and the wool will have a net positive charge. Conduction, think of the word contact, conduction, contact, as the charges from a charged body flow to a neutral body. As a result, the two bodies end up with the same charge. As we saw in our lab with the electroscope, the charged ruler, the electrons travel down, and the leaflets of the electroscope split apart. And finally, by induction, if I bring a charged object close to, for example, a styrofoam ball, the styrofoam ball ends up attracting to the charged plastic ruler, for example, and this is an example of induction. When you bring a charged object towards a neutral object, the opposite charges of your charged object will begin to accumulate. Remember, opposites attract. So, in general terms, when we talk about attraction and repulsion between charged bodies, like charges repel, opposite charges attract. These are opposite charges, they attract. Like charges, they can be both positive or both negative, they repel. So let's introduce dynamic electricity caused by the flow of electric charges. So for example, dynamic electricity is the electricity you would get in wires. Conductors are substances that allow electricity to flow through them easily, while insulators are substances that do not allow electricity to flow through them easily. There's a difference between conductors and insulators. Here's some examples. Okay, copper, aluminum, and iron are all metals. They conduct. Air, rubber, porcelain, glass, and wood do not conduct electricity, so they are called insulators. Current intensity is the rate of flow of electrons through a medium. and they are the number of electrons going by a particular point every second. And the unit of measure of current intensity are amperes or amps. 4 factors affecting conductance. Okay, what we need to remember: short, fat, cold, and copper. Okay, if the wire is fat, short, usually made out of copper, and a cold temperature, conductivity will be increased. So now let's look at circuits. We talked about amps. Now let's talk about potential difference. Is the difference between electrical potential energy per unit charge between 2 points. Basically, it's the energy that electrons have, and the unit of measure is V, or voltage, so we would talk about volts. Resistance is the measure of opposition to the flow of electrons in a medium or circuit. So how much something is slowing down the speed of electrons. And the unit of measure is ohms. And Ohms was famous for developing a formula called Ohm's law, called V equals IR, in which your potential difference is equal to your current times your resistance. Now resistance is the opposite of conductance, because the more a medium conducts, the less it resists, and the more it resists, the less it conducts. So there's a reciprocal relationship between conductance, which is G, and resistance is R. So R is equal to 1 over G, or G is equal to 1 over R. Ohm's law again, very, very important rule. V equals IR, and you could rearrange the values. R equals V over I, or I equals V over R. So remember, V is our potential difference measured in volts, I is our current intensity measured in amps, and R is your resistance measured in ohms. Important Ohm's law triangle: V equals IR, I equals V over R, and R equals V over I. In conductance, all you need to do is find the resistance and divide that by 1. So here's some examples here. Here's a current intensity when a stereo has a resistance of 300 ohms and potential difference of 200 volts. What is the current intensity? What I would do is put my given information. R is 300 ohms. V is 200 volts. Rearrange my formula. I equals V over R. So I equals 200 volts over 300 ohms equals 0.67 amps. Again, I have my units and my given information in my formula. What is the current intensity with an iPod as a conductance of 5S and a potential difference of 10 volts? Well, we know that our potential difference is 10. And what we could do is we know that G is 5S. R then would be 1 over 5. So therefore, our current intensity, I, equals V over R, which would be 10 over 0.2, which would equal to 50 amps. Important also is that since V equals IR, R equals V over I, and oftentimes you could plot a resistance graph by plotting potential difference versus current, which is a linear relationship going through the origin. So in any time, if I were to divide V divided by I, V divided by any single time, 2 over 1, 4 over 2, 6 over 3, 8 over 4, I always get a value of 2 ohms. So in a resistance graph, plotting potential difference versus current intensity, the slope of the line will always be your resistance. I would get my conductance by plotting intensity versus potential difference. So that would be the reciprocal. So now let's look at circuit diagrams. As an electric circuit is a path for the flow of electricity. So in a circuit diagram, we need to consider power supply, wires, elements that provide resistance, fuses and breakers that protect the circuit, switches that provide control, and instruments using and or measuring electricity. So for example, these are some of the symbol diagrams we need to understand. Resistor, voltmeter, measuring potential difference, ammeter, measuring current, a fuse to protect the circuit, switches to control, a power supply, and various types of lamps which are also resistors. This is a series circuit. So our power supply goes from positive to negative. These are lights. This is a parallel circuit because the circuit can take alternate routes. Series versus parallel. In a series circuit, the components are connected end to end and the current flows only in one path. One defective component stops the charges from flowing. For example, if you buy Christmas lights, 100 strings, and you pull out one light bulb, sometimes none of the lights will work at that point. The more resistance there is, the less current and the less power and the less energy. Parallel contains at least one branch and contains nodes, places where current splits to different paths and merges back. Defective components, however, can only affect current flow on the pathway it is on and not the entire circuit, and resistance is shared by all paths. Less resistance would mean more current, more power, and more energy. How to measure potential difference in current intensity? An ammeter would measure current, and a voltmeter which would measure potential difference in volts. An ammeter is always connected in series. Very important concept. While a voltmeter is always connected in parallel. And now in the final part, we're going to be looking at power. The power is the amount of work an electrical device can perform per unit time. And the unit of power is watts. The important formula for power is equal to V times I. In other words, power is equal to potential difference times current. And the unit again for power is W or watts. And in the power triangle, P equals I times V, I equals P over V, or V equals P over I. Finally, let's look at energy. Energy is equal to power times time. The unit of possible units for energy are either joules or kilowatt hours. So energy then, okay, in joules is equal to power, okay, times time. Power in watts, time in seconds. So joules is equal to watts times seconds. Or alternating, what you would normally see also, kilowatt hours is equal to kilowatts times hours. Remember that 1 kilowatt is 1,000 watts and 1 hour is 3,600 seconds. And here to enable you to transform between units. Units are very important here. You have to be able to alternate between hours, minutes, and seconds. Remember, joules equals watts times seconds, kilowatts, hours equals kilowatts times hours. Thank you.